Every second, high-energy cosmic rays, mostly protons from nearby exploding stars, strike the Earth's atmosphere. They strike the atmosphere with such force that they shatter atoms and create new particles. And among these new particles is the muon. Now that's a problem. Muons only last 2.2 microseconds, and even at the speed of light, 0.998 c, they should not last long enough to reach the ground, and yet they do. So what? Just invisible particles, right? Actually, they're proof that relativity is woven into our daily lives. Without the same physics that lets these muons survive, GPS maps would not synchronize their clocks with us, and your phone's map would be off by kilometers by the end of the day. Muons move at 0.998 times the speed of light. Multiply that by their lifetime, 2.2 microseconds, and you get a travel distance of just 660 meters. But the atmosphere is more than 10 kilometers thick. By classical physics, they should vanish long before ever reaching us. Clearly, something else is happening. Think of a movie. Normally, the scenes race by quickly. However, if you slow it down, the story expands and more happens in the same amount of time. Now think of the Muons movie. It's 2.2 microseconds stretched into about 35 microseconds, just enough for it to finish the 10-kilometer trip to the ground. Einstein's math explains this with the Lorentz factor, which is equal to 1 by square root 1 minus v square by c square. At 0.998 c, this constant is 15.8. Multiply the muon's proper lifetime, 2.2 microseconds, and we get 34.8 microseconds, exactly what's needed for muons to hit the Earth's surface. For the muon, time isn't slowed. Instead, space itself shrinks. Special and general relativistic effects make satellite clocks tick about 38 microseconds faster per day due to them moving at high speeds in weak gravity. That tiny error, left uncorrected, would be in your phone's map drifting by 10 kilometers every single day. In conclusion, muons prove that relativity is universal. It governs cosmic particles, orbiting satellites, and your next trip across stars. The laws of physics don't bend. They bend space and time themselves.